Now till here we have already understood why do we need stun, why do we need turn, what is NAT mapping, different types of NAT mapping. Okay, so now let's come back to this flow. Okay, so here we have already exchanged the offers, okay, and answers, which means we know the capabilities of both the peers. Right now the signaling phase is over. Now we are going to start the connecting phase. In that case, what happens? WebRTC gives you this ICE framework, which is inbuilt in the browser. Okay, which is built in the browser itself. The full form of ICE is nothing but interactive connectivity establishment. So what happens here? So whenever you are setting up this ICE framework, okay, while writing the code, you will set up the configuration for this stun and turn. You'll provide a URL. Okay, in case of stun, you just provide the URL to this stun, but when you are using the turn, you'll have to provide, authentication. Okay, username and password for this turn server, because this turn is not just responsible for giving you your public IP address, right? It is going to relay your packets. Your peers will have to register to this turn server. Okay. All right. So for that, what happens? You just give information to this turn and turn to this ICE. Okay, and then ICE does everything for you. This whole connecting part it will do for you. You don't have to do anything else for that. Okay, you will need to configure your turn and stun. For stun, you don't have to do anything. It's just publicly available because it's cheap. It doesn't do anything fancy for you. It just gives you your public IP address. So cost is not associated with stun. So you can find many free stun servers by Google available for you to use. But there are some costs because you have to run the server and you have to forward packets across. So it's not free. You'll have to set it up. So after setting this up and getting the stun URLs, you give those information to the ICE. And then ICE, what it does, it starts gathering all the addresses that can be used to reach you. Like for example, this peer. Okay, so this peer's ICE, for every peer will have their own ICE. Okay, so for example, in this case, for P1 case, this ICE will gather all the addresses from the stun, addresses from the turn, and then addresses routable inside the private network. Private network, what I mean, inside this network itself. Okay, whatever address it can gather, okay, it will gather. So all the possible addresses this ICE is going to gather. Okay, which is nothing but ICE gathering. Okay, so again, it's called ICE gathering. So this is the full form of ICE. Another term is ICE gathering. So by ICE gathering, it means it is going to collect all those public IP addresses, public mapping, okay, from the stun, turn, and the local. And all those gathered mapping, they are called ICE candidates. Okay, yeah. So now after ICE gatherings, after ICE gathering phase, you will get the ICE candidates, okay, in this side for peer 1. Similarly, P2, on the P2 side also, it will also have the ICE and it will also do the ICE gathering, right? So it will also have those ICE candidates. Once both the sides have gathered their ICE candidates, now let me just tell you one more important point here, because that can get confusing, okay, later on, and you might get stuck into some bugs, okay, while building this system. ICE gathering only starts, note that this point, ICE gathering only starts when you add media information. You add media information to this RTC peer connection. Okay, so in the browser, when you will start creating this offer and answer, during that phase you will add media information. Okay, and until unless you add the media information, this ICE gathering won't start. So just note that point. We'll understand this part when we'll go into the demo. Okay, then we'll know why I said this and how it works. Okay, so I just wanted to add this point here, okay, so that you don't forget and it doesn't get confusing later on. So once you have added the media information, ICE framework will start the ICE gathering, and it will collect all the ICE candidates, okay, in both the sides. Once this ICE gathering is completed and you get the ICE candidates, then one side will behave as a controller and other side will behave like follower. Okay, it will follow just whatever controller says, it will follow. Okay, so for that purpose, in the SDP, in the session description protocol, it will have a type like, you will see, okay, it means active and passive. Okay, so if it can behave active and passive both, then whichever peer starts the connection, okay, whichever starts the offer, okay, it will behave like active. And by active I mean controller, it will behave like a controller. These are all again buzzwords or jargons used in the WebRTC. That's why I'm telling you everything. Okay, so that it's clear for you. So one side of ICE will start behaving like the controller, and what it will do, even before behaving like a controller, there is one more thing that you have to do. You have gathered your ICE candidates right in the both side. The ICE gathering is done. ICE candidates you have. Now what you do with these candidates, you have to send those ICE candidates other side. Again, how you send it? You send it through the signaling server. Okay, so P1 sends its ICE candidates. Okay, and similarly P2 will send its ICE candidates to P1. Okay, now the controller side, what it will do, it will have ICE candidates from both the sides. So once this controller side gets all the ICE candidates from the other side, what it will do, suppose it has C1, C2, C3, three candidates on the P1 side, and from the P2 side it got again like CP2, CP1, CP2, CP3. Okay, like this, it got all these candidates from the other side. What it will do, it will start making the pair. Okay, it will start making the pair like this and start testing the connection. Meaning, suppose it selected this pair C1 and CP1, what it will do, using this pair, what it will do, it will send the packet, the P1 will send packet to the CP1. Okay, and from the other side it will expect the response to come to this C1. So if it is able to connect through using these candidates, it will calculate something called latency and other thing. It will calculate some metric, okay, which will make sure, which will be deciding factor to use which pair among these. Okay, which pair. Okay, so similarly for every pair it will do the connectivity check, and finally based on the metric will be like checking latency and all, like how fast is this pair, how fast is this pair. So it will find the best route. Okay, it will find the best route using which the connection should be established, whichever route is the fastest one. Okay, so based on that, suppose these two are the pair that you can use, the ICE can use to establish the fastest connection. Okay, once this is selected, this will be nominated. Okay, this will be nominated for the connection. Okay, this phase, the connection phase, will be done here. Okay, the connection will be established. This will be called as connection established. Okay, till here the connection will be established. So now till here we have understood the signaling phase. Okay, and we have understood the connecting phase also, like, right? So now in the connecting phase, you understand what is ICE, what is turn, what is NAT, right? So till here I hope everything is clear. Okay, now let's go into the turn phase. Okay, let's understand turn a bit more. Okay, till now we have understand why everything is required and how it works. There are some more important information on the turn, how it works. Okay, so let's understand that part. Okay, so suppose you have this turn server. Okay, you have this turn server. Now we know that every turn server will have its own turn, right? That part is clear. Okay, now you have this peer 1 here. Okay, and you have this peer 2 here, right? And this P1 wants to connect to P2, but in this at this time it can't connect for the NAT mapping reason. It can't connect directly, so it has to connect through this turn server. Okay, so for that, what happens, I've already told you, this turn is an authenticated server. Okay, you need username and password, right? Username and password. So what happens when you give this information, turn information, to this ICE framework here? Okay, what it will do, it will register you to this turn server. Okay, using this authentication, username and password, that information will be sent over here, and it will see, okay, you can, since you have username and password, I'll let you register to my server. Once this is registered, what all happens is there is something called allocation. So the peer 1 will create an allocation here. Again, this is another jargon I'm telling you. Okay, this allocation is nothing but the mapping, those public and private IP address mapping, IP plus port mapping. Okay, so that mapping will be created here, so that same mapping will be used to connect, right? And that same mapping, this allocation, this mapping, is nothing but the ICE candidate again. Okay, these are all the same thing. Okay, so whenever you see ICE candidate, it's nothing but this mapping, and that mapping is nothing but the allocation, and this allocation is specifically used term for the turn. Okay, for the turn server you use the allocation term. Okay, so these three things are same. Okay, now once the p1 is registered to the turn server, okay, this allocation will be created. Now p1 wants to communicate to p2. Okay, suppose p2 is also connected to this turn server, okay, or another turn server. They can connect to any turn server, okay, but after connecting that, you'll get this mapping, right? And that mapping will be nothing but the public IP address, right? This mapping will give you the public IP address, so you can exchange the public IP address and then you can connect, right? So this p1 is suppose connected to this turn server and it created that allocation, and similarly p2 also connected to this turn server and it also created another this allocation for the p2. So both have the public IP address created here, public mapping. Now p1 wants to connect to this p2. What happens now? In order for p1 to connect to p2, it has to send this mapping, right, to p2. So what happens here? Before p1 sends this mapping to p2, it creates a permission. It creates a permission on the turn server for this p2. Okay, after creating this permission for this p2, it sends this mapping through the signaling server directly to the p2. Okay, this permission was created so that once this mapping is this allocation or mapping or this ICE candidate was sent over to p2, only p2 will be able to use that ICE candidate or mapping, okay, to send back the response through this turn server. Okay, through this turn server, only this p2 should be able to do. Okay, what if you have sent this mapping to p2, okay, but someone in the middle got this mapping and they start sending back the response instead of this p2. So this man in the middle can happen, right? Or for some malicious reason, this p2 gets this mapping and shares this p2 this mapping to someone else, to p3, and p3 can also send back the response. Okay, so for the security purpose here, the permission gets created so that whoever you wants to communicate with, only that peer will be able to send back you the response. For that purpose, this permission gets created. All right, I just wanted to cover this part so that it's clear. Okay, so that's how turn server works. Okay, so once you have exchanged both the peers, just the way p1 created the permission for p2, when p2 sends the mapping to p1, it will also create the permission for p1, okay, on the turn server. That's how they create this connection. After creating the permission and exchanging those mappings, okay, both sides, this connection will be created, and not like this, the connection will be created through, let me use this, the connection will be created through this turn server. Okay, so here the connection will be created. All right, so I hope till this it's super clear. Okay, so now the connection phase is complete with the turn server as well. Okay, so now we are super clear on the signaling phase and the connecting phase, right? Now we know why ICE is used, why stun is used, why turn is used, how turn works, and what is NAT. Okay, so we understand everything now. Okay, so till connecting phase it's clear. Now in the next video we are going to go into the securing part. Okay, so in the all four phases, this is what is the most complex part and most confusing part that people struggle to understand. So if you have understood till here, okay, pat yourself on back, you understand most important part of WebRTC. Okay, these two parts will be piece of cake for you to understand. All right, see you in the next tutorial.